Look up at the night sky. The stars you see could be hiding a world of its own. A world with mountains, oceans, or maybe even life. But how do we uncover these hidden worlds when their signals are lighter than a whisper in a storm?
Let's step back for a moment. Who are we? Team NeuroCatch. And I believe you guys are really excited to know what do they bring to the table. Ahir Tajwar Akash, Project Manager and LLM Researcher.
This is Mahir. Imagine you're talking to your machine about your favorite world, and the machine replies you back with certainty. Now you started thinking, is it truly an exoplanet, a distant home drifting in the dark, or just a trick of the cosmos playing with their eyes? We are trying to build something like that.
Not empathy for the problem. For years, researchers have struggled to detect exoplanets. The work was manual, time-consuming, and overwhelming. Scientists had to go through endless telescope data, often missing subtle patterns that could reveal entire new worlds. Meanwhile, curious citizens who wanted to participate in the discovery of planets found the process too technical and locked away behind academic tools. That's where Project NeuroStar comes in. We have built a solution that bridges the gap, making exoplanet research faster for the scientists and accessible for everyone. With 93.5 and 9% accurate machine learning model, a Llama 3-powered chatbot, and a deployable in-8M workflow, we don't just automate exoplanet detection, we democratize space exploration.
Hello everyone, welcome to Project NeuroStar, our solution for a world away hunting for exoplanet with AI. We have built this for two types of user: researchers, scientists who need accurate academic result, or citizen scientists, curious people who want to explore and learn. The project has three main sections: ML models, chatbot, and N8N workflow. Let's talk about ML models and what we have done. We have worked with the Kepler object of interest dataset. First, we handled missing values, performed feature engineering, and prepared the dataset with target encoding and feature selection. We split the data into train, validation, and test sets. We handled class imbalance with smooth and scalar features. Then we trained multiple ML models like XGBoost, LightGBM, CatBoost, and Random Forest. After validation, we combined them using an ensemble prediction function, achieving 93.59 accuracy. Here's what researchers can do with ML models. They can input data to get instant prediction. They can upload CSVs for downloadable prediction result. They can train model with custom parameters and CSV files. All models, scalars, and training columns are saved as pickle files, and we have connected everything via FastAPI for seamless integration. Let's talk about the chatbot and what we have implemented. Users can upload CSV and query results like "show me a few rows." Users can interact naturally through conversation. Users can use text-to-speech for accessibility. The backend uses Grok Cloud API, and the model is the freely available Llama 3. Here's what we have done with the N8N workflow. It is fully deployable to help researchers replicate the project easily. It integrates the GPT OSS model for LLM-powered response. It supports CSV uploads for inputting dataset. It includes an automated mailing system for sending result. Also, it automates ML tasks like pre-processing, predictions, and report generation. Finally, it provides a visual drag-and-drop interface so pipeline can be run without coding. So finally, here's the technology we have used. We have Dockerized ML models, chatbot, and N8N workflow for easy deployment. Our backend deployed on AWS EC2 instance and also fronted on Barcel. We have used FastAPI that connects ML models and chatbot endpoints. Finally, we have used Git LFS that manages large files like models and dataset. Here's what the project is all about. Project NeuroStar empowers both researcher and citizen scientists. It combines AI ML models, a Llama 3-powered chatbot, and a N8N workflow for intuitive data exploration and reproducibility. It provides downloadable results, model training, interactive queries, and automated workflow, making exoplanet research accessible for researcher and citizen scientists.
Human eyes can't keep up. Some planets, maybe even an Earth like one, were missed. A tide spring to become an astronaut, a scientist breakthrough, a mission to success, they all depend on what is buried in that data. That's why we need AI. Imagine opening a photo, the screen fades into starlight, and suddenly you are standing at the edge of the universe. A glowing telescope hovers in front of you, pointing towards endless galaxies, inviting you to look closer. One tap and the cosmos opens. No clutter, no noise, just you and the stars.
Are you guys ready to explore our project with us?